We've looked at the basics of point plots. Let's dive a little deeper. So specifically, we saw that we use a formula expression to tell the function point plot what exactly we want to plot, right? Of course, we are saying we want a point plot, but what variables to put on what axes? And we used a formula expression for that. So let's dive a little deeper into formula expressions. So this is what we had done earlier, or anthro underscore f, which is the name of the data frame. And then we use the pipe operator, which is the vertical bar followed by the greater than sign. And then we call the point plot function. So which means that we are taking this data frame, piping it into the point plot function, and then giving additional information about what we want how we want the point plot function to behave. So we are saying put wrist on the y-axis, put ankle on the x-axis, and for every point which exists in the data frame, take the wrist values, ankle values, and uh, plot them with a single point on the chart. Okay, so wrist tilde ankle, that's a formula expression, and it's sort of a way of saying y is a function of x. We are looking at the how the pattern of x has any influence on the pattern of y. It's just a relationship that we are trying to look at. So this is kind of the mathematical, we are used in mathematics to use y equals f of x. Okay, and that's what this is mirroring. Except that instead of the equal sign, we use the tilde sign because this is not a mathematical function. That's all we are doing. Okay, so y is the response variable, and we put the response variable on the y-axis, and the other variable, which is also called as the explanatory variable, we put it on the x-axis. And later on, we'll see what we mean by explanatory. Why is it called as an explanatory variable? Okay, so that's what the plot looks like. Okay, so this is the same AnthroF data set. So if we look at another plot, right, we've got waist on the x-axis and body fat on the y-axis, right? Earlier, remember, it was different. Earlier we had said wrist and ankle. This time we want to plot waist and body fat. So what might be the formula expression that will produce this plot? It's very clear, right? The plot is a point plot, so we can say point plot is the function that is used. AnthroF is the data frame, so we know that. So all we have to determine is what is the formula expression used? Well, we see that body fat is on the y-axis, so obviously we're going to say body fat tilde waist. Okay, so obviously it's going to be b fat tilde waist. That would have been the would have been the formula expression to generate this plot. Okay, so it's very straightforward, right? If you want to put something on the y-axis, something on the x-axis, we can always say, whatever we want to put on the y-axis, tilde, whatever we want to put on the x-axis, and there you go, you get the plot. Now, of course, these column names, the variable names, must exist in this data frame, right? Because you're saying from this data frame, put b fat on the y-axis and waist on the x-axis, right? If those variables don't exist in the data frame, then of course you'll get an error message. Nothing drastic is going to happen, nothing bad. You'll get an error message. You'll say, oh, okay, I know what mistake I made. That's it. Okay. Now that is fine so far as both of the variables being quantitative variables. Now, what if one of the variables is a categorical variable? Then what? Okay. So here we've got this plot in which you've got on the x-axis, you've got some, this is a data of penguins, I think, correct, different species of penguins. Okay, so here are three different species of penguins, and on the y-axis is the mass of each of the penguins. Okay, so we've got a big data set of penguins, and therefore the unit of observation is a single penguin. And for every penguin, we've got a lot of data. Among them, we have one is which is the species to which they belong. And this another column we have, another variable we have is their mass. Okay, mass being weight in grams. Okay, so this is how the plot would look if you plotted it. Now notice that on the x-axis, unlike if the x-axis were a quantitative variable, then you would have a whole range of possible values. But here our x-axis is a categorical variable and there are only three possible species in our data set, and therefore we can only have things falling at three different places here. You can't have values going all the way because there are only three different values of species. Okay, so now what happens is for every penguin of a given species, they've got the weight, the mass, which is plotted here. Now every point could be representing many penguins, right? So for example, if you take a mass of this, okay, it is possible that there are several penguins of this species, ideally species, who have the same mass, in which case all of those points will overlap with each other and we are not going to be able to see how many points there really are. Okay, to open it up, we use a technique called jittering. Okay, which is, even though all these points are falling on the same spot, let's jiggle them up a little bit so that we are able to separate out the different points. Okay, so that is what this does. So this plot was generated using point plot, and point plot automatically jitters the variables. Okay, so rather than showing ankle as the species as a single point on the x-axis, it kind of spreads it out so that we are able to see better the distribution of points. Okay, so there's a lot of overlap, and here through jittering we have reduced the overlap. And the good thing is point plot does this automatically. We don't have to really tell it anything extra to do this jittering. And the code, of course, here, if you look at the plot, the, the species clearly seems to have some effect on the mass. At least it could turn out that these two species have kind of similar masses. You see the spread is the same, the spread of mass. Okay, although for this particular species, most of the points seem to be concentrated somewhere in the middle, whereas here there is a bigger range, so there's some information there. But very clearly, penguins of this particular species in general tend to be heavier. In general, of course, there are some penguins of these species which are actually heavier than some penguins of these species, but generally speaking, they tend to be heavier. So clearly, there seems to be a relationship between the species and mass. Okay, of course, there is still a lot of variability within each species. It's not as if given a penguin of a particular species, we can point out exactly and say this is going to be its mass. No, there's a spread, there's uncertainty, there is variability. And as we have said earlier, statistics is really the study of variability. Okay, now maybe if we add another variable, we may get some more clarity, right? Meaning we are trying to see, okay, for penguins of a given species, there is variability in the mass. So even within a species, can we bring some other variable into play that gives us better visibility into what is this, what can explain this variability, right? But we have only two axes, the y-axis and the x-axis. How can we bring another variable into the picture? Well, actually, we can. Okay, so here what we are saying is, okay, we are going to use the x-axis for the bill length. So the new variable we are bringing in is the bill length, the length of the bill of the penguin. And we are now seeing the relationship between bill length and mass. But we also want to squeeze in information about the species. Well, we can do that because we can bring in a third dimension through color, right? So we color the penguins of a different species, with different colors, and then we show the relationship between bill length and mass. Okay, so clearly we are seeing that in general, longer bill lengths imply greater mass. Okay, more likely because if a penguin has a longer bill length, it is probably older. The bill has grown over time. And because it's older, it probably weighs a little more. Okay. Now, clearly, within each species, we are able to see that relationship holding between bill length and uh, mass. Okay. Now, one other thing we are also seeing is the penguins of this particular species all have somewhat smaller bill lengths than penguins of this species. Okay, consistently, because you're seeing all of those points are uh, separate; they're clustered together here. Okay, so that is interesting. That is something that just by looking at the data we would not have figured out, that penguins of this particular species generally have longer bill lengths and also have higher mass than penguins of this species. Okay, now penguins of this species interestingly seem to have longer bill lengths but consistently seem to weigh less. Okay, so what we've done is by adding another variable, namely the bill length, we are able to get a better insight into our data. Of course, in order to generate this plot, we would have said penguins pipe point plot, which is the function. Now the formula expression, of course, mass is on the y-axis, so we'll put mass tilde bill length. We want bill length on the x-axis, right? And then we want species to be shown through the color. So we put that as the, on the right-hand side, we put it as the second variable. Automatically, the point plot function says, okay, the first thing I'm going to put on the y-axis, the second thing here, the first thing after the tilde is going to go on the x-axis. The next thing, if you have any, is going to be used for coloring. Okay, all of these decisions automatically the point plot function does. Okay, so this is a little bit more complicated formula expression than what we saw earlier. Okay, of course, this we've already seen. What can we say about the relationship of bill length and mass for the three species? Does the plot illuminate more than the earlier plot? Definitely, this plot is far more illuminating than the earlier plot. We get a good idea about these things, right? So, for example, for this particular species, we can say on average the bill length is so much, and on average the mass is going to be somewhat so much. And whereas for this species, the on average the bill length is so much and the mass is so much, and so on. So we are able to say more about the relationship of bill length to mass, and we are able to explain the variability of mass better. Earlier, we were only looking at how the mass varies based only on the species. Now we are able to say how the mass varies given the species and the bill length. Both have an effect on mass. Okay, so with two explanatory variables, the mapping goes like this. What we put first goes on the y-axis. What we put second, which is right after the tilde, goes on the x-axis. And what we put after that is used for coloring. Okay, so that's about formula expressions.